A real laser beam can only approximately very close to a Gaussian beam distribution, the energy distribution, the oxidation layer on aluminium. You must use very sharp light. Hi everybody, welcome to Jelly Talk. Today we're going to talk about the beam quality, the Gaussian mode laser, the single mode laser, and the multi-mode top hat laser. What's the difference? How to choose them? I've been talking about this topic 2 years before, the difference between single mode and multi-mode. And there are, I believe, many of our customers or people who buying laser cleaners, you know that you need to choose between single mode and multi-mode. And I want, sometimes more education in the market, more customers came to us and they are very clear or determined. They're going to buy a top hat laser or they're going to buy a single mode laser. I want to make sure that both of us, all of us, are in the same common understanding of this definition. I feel that I need to talk about it again is because, especially after the launching of our GT500, because our GT500 is kind of a combination of both single mode and multi-mode, or let's say between. So this caused a little bit misunderstanding or a little puzzling for me or even for most of you. That's why I want to do it again today to completely explain what this definition means. So first, we need to talk about the definition, beam quality. What is beam quality? Beam quality is a dimensionless value, which means that it's the relationship between two factors that is divided or is plussed. So it's actually, we can see this function, this equation. It's a Gaussian beam. Gaussian beam is dimension is value which named it m squared. So you will see this number or specification in the manual of the laser source or your machine, which shows that the beam quality of the laser source is m squared equals to 1.5, or m squared value is 2 or even 12, something like that. So what does it mean and how to choose it and how it affects our cleaning effects? So first, when we talk about the beam quality, we need to bring out the Gaussian beam, the best beam quality. The m squared equals to 1, which is the equation we look here. So all the parameters means from the energy distribution cloud diagram, we will see that a real laser beam can only approximately very close to a Gaussian beam distribution, the energy distribution, because this is the beam shape of a Gaussian beam. From the energy distribution diagram, we see that a real laser beam can only approximately very close to the distribution of a Gaussian beam, which looks like this. And if the Gaussian beam m squared equals to 1, and this is theoretically 1, but a real laser beam can only, go as sharp as possible, but you will not, get to the theoretically the dimensionless value 1. So mainly in practical, the m squared, we will see that from this equation, the shape of the beam decides the quality of the laser beam. Normally we call it m squared value less than 2, we call it a single mode. And this is a Gaussian. And m squared value bigger than 5, we call it multi-mode. And pay attention, it's not absolutely right. I mean, it's just what we believe is like this. But I check with the engineers that most of the engineers or scientists or manufacturers, they agree that m squared less than 2. We agree that it's a single mode. And for which kind of mode you call it a multi-mode, either it's 5 or 6 or 7 or 4, this depends. So I want to bring it up that if you are buying a laser, you ask the manufacturer if you are a top hat laser, they say yes. So actually, this doesn't mean anything. So you need to know that what kind of top hat you want. Because for top hat, you go probably not so sharp, and you go the beam like this. And even you have different shapes. So you got different value. So you got 8 or maybe 10 or 12. So actually this will affect the cleaning speed or effectiveness, we will see that after we will make a test. And today we have two machines. One is single mode M square 1.5. One is a multi-mode M square 12. So we will compare these two machines in the same material, how it cleans and what kind of things, speed and effects you get. And another way we explain the beam quality. Of course, from the equation, we know the value of the M square, which make it easier that what we're talking about the quality. Another way that we will see from the energy and by a thermal interferometer, when you shoot the laser in the surface of a material, normally we divide the energy area into three areas, which in the center is the very center and which the temperature is very high. And then there is the second region, we call it the area besides the central. And then there is the edge. So their temperature are different, which means temperature, because it's the energy that you put on there, is different. We will see from the test equipment that the single mode and multi-mode, they have different space of the areas, which cause different effects in the materials. And then simply we see that single mode has very sharp, if you compare that the laser tool as a knife, I mean in the kitchen, and this single mode is very sharp, so you can chop or you can cut very deep or quick with this sharp tool. Then if you go with a multi-mode, you probably splash, or maybe you don't use the sharpness of this knife, but you put equal power and you put more energy on that. Let's see how it affects working with the two lasers. Okay, now let's go and make the test. So after all the tests, we came to the conclusion. For samples like this, the oxidation layer on aluminum, you must use very sharp knife, which is a single mode. The M square value has to be as low as possible. Then actually this one is cleaned by the single mode laser, and this is multi-mode. You actually cannot work on that. And for the modes, this is for making some small parts, intricate parts. For these kind of things, because you need to protect the base material, they're very sensitive to the energy of the laser. In these occasions, you need multi-mode, the top head or the M square as bigger as possible. So you protect the base material and also you get the speed. And for something like this, very, very thin, and they are very also very sensible to heat and very easy to get distortion if you work over time on it. We also recommend single mode because the energy is small. Every single mode laser, every pulse is smaller millijoules in energy. And for paint or rust, especially for rust, it's very easy to take off. You don't need very sharp knife to work on that. You need blunt, so you use top head or multi-mode or bigger M square value to have equal surface after cleaning and to have faster speed, higher efficiency. So this is simply the conclusion for what we're talking about, how to choose and what do you mean by a single mode and a multi-mode. It's a beam quality, it's an M square value, and it's the shape of the beam when we work in this cleaning industry, actually we test every laser with different cleaning, different materials. We customize laser source. So let's come back to our GT500. It's something the M² value is not smaller than 2, not bigger than 5. So that's why I always explaining to you that it's a compromise, it's a combination of single mode and multi-mode, which allows you to be powerful in many scenarios, that you can take off the very strong attached layers, but you can also gain high speed and protect the base material. So that's why we customize the laser source. And we will keep, besides our standard products, we also provide solutions like the inline production, or you are devoted on certain kind of cleaning. We can also customize the best quality beam quality lasers to match your special applications. So besides the beam quality, the M² value, is this the only thing that affects the cleaning? I mean, when you are choosing a machine, you're buying a 300 watt single mode laser. It's the only thing that you need to pay attention. Let's see some test example. We use a 300 watt single mode 1.5 millijoule, and then we make the same cleaning on the same material, the same parameter, but with different field lengths. F160, F254, and F420. Let's see how it goes. So after this, you know that M² value is very important. But besides that, the beam pass, how to choose the beam pass configuration is also very important. And this we'll talk about it in the next video. See you next time. Bye.